let's suppose what we've done is we've asked, oh, by the way, before we do this, I think it would be a good idea to watch the other videos on chi-square because they have the foundational ideas. I don't want to take time to keep going over the same little nuances of each test. So we're going right into this one. Probably watch the other videos if you haven't. But we're doing a chi-square test of independence. Let's suppose we just took a survey of people and we said, hey, for those of you that eat salmon, how would you rate farm-raised salmon? Some said low, medium, high, or whatever. How would you rate your love of the taste of wild salmon? And we rated them low, medium, high. So these are our results. In a chi-square test, the null is going to be there's no association between the type of salmon and the rating that they get, and the alternative is that there is an association. So basically, if there's no association, it doesn't matter which type it is, the distribution should be about the same. So then we do this like the other chi-squared tests. We're going to say, okay, look, if the null is true and there's really no difference between these two distributions, then overall we had 25 out of 81 people rating the salmon low. So if these two are the same and there's no association between this variable and that one, then we would expect out of the 42 people that were asked about farm-raised salmon, we would expect that out of 42 of them, 25 81sts would say I would rank them low. And that would turn out to be 12.963. So that would be the expected count if there's no association between the type of salmon and this. Likewise, overall, we had 26 out of 81 people say that their preference of this or their taste regards to this would be 26 out of 81. So in this sample of 42, we would expect that row total times this column total divided by the grand total. We would expect that 26 81sts of this group and 26 81sts of this group would rate them as medium if the null were true. So again, watch the other videos if we're not quite sure about what we just talked about there. So this is the chi-squared test, and it's the chi-squared test of independence on salmon and ratings. Those are the two variables in the two-way table. The null, again, that salmon type and rating have no association. The alternative is that they do have an association. Make sure all the expected counts, we can say in this case all the expected counts are at least 5, and that the data was from a random sample. Now, where are we going to get our results for p-value and the chi-squared test statistic? Once again, we can go to the calculator, we can go to a matrix, we can go into matrix A, and we're going to configure this one as a 2 by 3 matrix. So again, I can go back here and we can take a look at what the counts were. It was 19, 15, and 8. So we're going to go 19, 15, 8, and for the other it was 6 and 11, and sorry, that one was 22. So all the observed counts go into a matrix. We can go run the stat test again, and this is a chi-squared test, so both the test of independence and the proportions, we choose this one as opposed to the goodness of fit. Remember, the calculator will reconfigure all the expected counts and put them in matrix B. So here we go. Our test statistic is 13.8. We get a very small p-value. So because the probability of a type 1 error is less than 0.05, we reject the null. So this is the test. A couple other things worth mentioning with the chi-squared goodness of fit. And again, you could have many different distributions. You could have 2, 3, 4, 5 rows, whatever. But bottom line, think about it this way. If we've looked at the linear regression t-test, there's a connection here. The null for this test is that there's no relationship between these two variables. Call this variable x and this variable y. Because these are categorical variables, or at least one of them is, well, they both are, then this is the right test to see if there's a relationship. But there's another test to see if there's a relationship or an association between two variables, but it's if the two variables are quantitative, like time studied for the AP exam and the score that you get on the AP exam. And then we'd see data displayed in a scatter plot, and we'd run a linear regression t-test to see, well, the null would say that there is no linear relationship, which is to say that beta, the slope, is 0, and the alternative would be that there is a linear relationship, which is to say that beta is not equal to 0. So if you've studied this test by now, then you realize, oh, there's a connection. We're seeing if there's a relationship between two variables. If they're quantitative, we can see if there's a linear relationship. That's a linear regression t-test, data displayed in a scatter plot. But if the two variables, or at least one of them, is categorical, then we can still see if there's no relationship or there is a relationship. No relationship is a relationship. But the two variables are categorical, so the data is displayed in a two-way table. Two variables, two ways to connect them. All right, lastly is this. There's actually 3 sets of hypotheses, really like 4, if you're running a chi-square test of independence, and it's all based on the question that's being asked. If the question asked is, hey, is there an association? Is there a relationship? The null is no relationship or no association. The alternative is that there is a relationship. Now, we might be asked, is this evidence to suggest that the two distributions are different? In that case, the null is the distributions are the same. Because remember, if there's no relationship, we're expecting that they're the same. That's how we were able to get the expected counts in there, by doing row total times column total. And then the alternative would be that the distributions are not the same, that there is a relationship, that we tend to get higher ratings for the wild caught than we do for the farm-raised salmon. And then lastly, where the test gets its name, is that the two variables are independent. That type of salmon and rating are independent of each other, meaning that it doesn't matter which type salmon you get, the ratings are going to be about the same. That makes a little bit more sense if you see the alternative. The alternative says that the two variables are dependent, which means it depends which type of salmon you're looking at as to what the distribution of ratings would be. So the distributions would not be the same, and there would be a relationship. It matters which type of salmon you're with as far as what the rating is. So that's an idea of the chi-square test of independence. So good luck with those.